Alright, so now that we've written our algorithm, let's take our algorithm and program it. So you start with step 1, which was to gather input from the user of the weight and the radius. So we'd like to tell our user to enter the weight and the radius, so we'll have a cout statement that says enter the weight of the sphere, and we'll let the user enter in that weight. We'd like it to make it a variable up here at the top, and our weight, if we think about it, it might have a decimal place, so we'll make him of type double. Our radius as well might have a decimal, so we'll also make it a double. And so we have our cout statement, enter the weight of the sphere. So let's use our cin to enter in that weight, and then we'll copy and paste these lines of code to enter in our radius. So our next line of code here can say, please enter the radius of the sphere and enter in that radius. Now, we'd always like to have a working program at the end, so one of those things that you could always do is test your program as you go. So to test that the user entered in the correct weight and radius, we can output the weight that you entered and output our weight to make sure it was entered in correctly. And then we can do the same thing for the radius. So double click Control C, double click Control V. That's how we can copy and paste code really quickly. Alright, so let's compile and run this code. The code says enter the weight of the sphere, 34.4. Enter the radius of your sphere. Alright, it looks like everything worked correctly. And since I am using code block or DevC++ here, it does require that I put that system pause in there so my window doesn't flash by. Alright, so we've tested that step. Let's go on to step 1.5. Step 1.5 was to calculate the volume. So I'll paste my step down here, and let me move my code window up here so you can see. So we're going to need another variable of type double, and we'll name him volume. And since we've written our algorithm pseudocode-like, we can take that line of pseudocode and paste it right into our program. Now 4/3 is an int divided by an int, so remember to put that 0.0 on one of those, times pi times radius times the radius times the radius. And let's define pi as a constant. So remember how to define a constant. It's on page 19 of your text. Use the keyword const. Notice it turns black. It is a keyword. And then you say what type of variable that constant is going to be, and our pi will be a double. We always name our constants with capital letters. And then we will give that constant a value up to 6 significant digits. Alright, so let's test our code again. Enter the weight of your sphere. Enter the radius of the sphere. And it looks like all is working. Now we forgot to output our volume, so it would be a good idea to output our volume so that we could see that it did indeed calculate correctly. Now, to make sure that this is calculating correctly, we should desktop test this. So that means you figure out what the volume is with a regular old calculator, okay, not through the program, and make sure that the program output and the calculator output will be the same. So I'll let you do that on your own. So let's test it one last time to see that the volume is indeed being calculated and isn't 0 or something. And that is the correct answer that I calculated earlier. Alright, so let's move on to the next step. It says step 2 was to calculate the buoyant force. Alright, so we'll come down here and calculate our buoyant force. Notice that we paste our steps right into the problem here. Now our buoyant force step was written pseudocode-like, so we can just paste it right in there. We do need to declare the buoyant variable of type double, buoyant force variable, and the specific weight of water we also need to declare him. Now the specific weight of water, we could declare him as a constant, or if we wanted to, we could just make him a variable type right up there, and it is 62.4. So, alright, now to test that the buoyant force is working, let's copy and paste this C out statement. So remember, select Control C, put it where you want, Control V, double click Control C, double click Control V, and we can calculate the buoyant force. Of course, that's not what you entered. This would be is, and this one also could be is. Alright, we should test our code now that we've changed it specifically, and of course we got a syntax error because we forgot to tell it that this was a variable of type double, which is why you test as you go. Okay, so now we can enter in our input. It calculates our output, and that all looks great, but we aren't finished with the program. Remember steps 3 and 4. Steps 3 and 4 stated that we need to test this buoyant force to see if it's greater than the weight. So this is where we do our branching statement. And we wrote our algorithm, very pseudocode-like, so we can cut and paste that right in there, and copy and paste it. And it says if the buoyant force is greater than or equal to the weight, then remember that we need to see out that the sphere will float. Otherwise, we output that it will sink. Now I am completing step 4 here, but 3 and 4 kind of go together, and so I think that's okay. Actually, let's print out just the words the sphere will float or the sphere will sink. Alright, so we did actually program step 4 with step 3. So let me cut and paste that down here. Alright, now we need to test our code. So I'll hit the run and compile button, compile and run button, enter the weight of the sphere, enter the radius of the sphere, and the sphere will float, which is what I expected it to be. Remember that you should have calculated these numbers on your desktop so you know that they are correct, which I know that they are. So it looks like we have a working program. Excellent. So remember what we did. We took our steps from our algorithm, we programmed each step and tested as we went, and at the end we have a working program.